What am I doing? Hello, and we are live. It's a good evening to see you all. Thank you for joining. Glad you could all make it. Yeah, it's quite hot here again tonight. I'm sure it's even hotter than last night. I think last night was 27 degrees, so it has to probably be hotter tonight. Hope you're all doing well. Hope my sound is doing okay. How's everybody doing? Today I was thinking I'm going to be talking about relative density disequilibrium, because it's a subject that a lot of people don't really understand, and if they think they do understand, they don't really get it. So I thought that would be quite cool to maybe go through it a bit and maybe try and explain it to see if people really get it. Right, Owen, good to see you. Thank you for coming. Glad you could make it. Merle's conscience. Time can be an IV and DV. The sources you read supported that. I'm happy to help you with your education. Most, we've been through this already. I showed you why those things are pseudoscientific, and this is not about science today. Tonight it's about relative density disequilibrium. Just because you are pushing pseudoscience does not make it science. Just have to tell you that. Okay. What's up? What up, Jess Palmer? Good to see you. Thanks for coming in. Yeah. Owen, I love relative density disequilibrium mechanics. Yes, everybody does, because it's reality. It's a scientific fact because it's been hypothesized, validated with experiment, and can be reproduced the whole time. So it's very simple. I created a poll today. Do you understand relative density disequilibrium? Out of 8 votes, we get yes, we get no for 12%, and almost there with another 12%. So that means yes is 75%. Yeah, that about sums it up. At work with flat and level, exactly, flat and level. Moles Conscious still talking about DV and IV. I'm here to help educate you. Is that so, Moles? You can always come in and actually talk, so we can, so I can educate you on, because you simply don't get, there's no such thing as time being an IV and a DV. Time can only be a control because it's a duration based on reference. That's it. You cannot manipulate time. You can only take a reference of a duration of time. That's about it. Sorry to disappoint you, but like I said, tonight's topic is relative density disequilibrium. I thought we're going to start off with something that's actually quite well known. Actually, I'm also going to be doing a demonstration for you myself. So maybe let's maybe show the demonstration. I think we're going to do the demonstration and then we can explain why this happens with the demonstration. Obviously, this is just a normal flask, well, container, plastic container with some water, tap water, so normal H2O. This is a plastic block, okay? I'm just gonna first empty it out because I put some money in there, some coins, so it can give it some weight. This block has density to it. What happens when I put this block into water? One of them has to be less dense. What do you know? It floats. So this plastic block is less dense than the water it's in. Obviously, you can also say, okay, even if it's a bit denser, it's maybe displacing the water around it, and that's why it's floating. Hi, PJ Crushing, thank you for coming. Really do appreciate you coming in. Thank you, everybody. Thank you, all my members. It's good to see some members here. Great. And please, if you haven't already, just hit that like button and share. Well, anyway, so you see it is less dense than the medium it is surrounded in. More dense than the air, so the air cannot support it. So that's why it drops, and it's less dense than the water, so the water can support it. What happens now if I'm going to make this object denser? You ask me now, how are you going to make it denser? Because density is already set, it's per cube. Exactly, but you can make the system denser than the medium. So you're adding more weight because you're putting more mass into the system. I'm opening it, you see? I'm going to be adding the coins. This gives it more weight. I'm making the object, the system, denser. Remember, it floated a few seconds ago. What happens now? It's still denser than the air, so it's going to fall still, and now it's going to be denser than the water. Oh, is the water able to support it now? No, because the water is now less denser than the object. Remember, the density per cube is still the same, but the system is now denser. This is why I was explaining, when you put something of more substance together in the system, you make the system denser. Hence, relative density disequilibrium. It has got to do with the surrounding medium. So if the surrounding medium is not able to support it, hence pressure, then the system, like this block, has the pressure. That's where the force comes from. The pressure is the force. It mediates itself to equilibrium because it was out of this equilibrium. I simply picked it up. I added energy into the system. Okay? I added energy. So when I picked it up, where do you think it's going to go? It's going to its relative equilibrium point. The relative equilibrium point would be at its density layer. So it's denser than the air, it's going to drop through the air. It's denser than the water now, so it's going to drop and sink through the water. If I take that weight out again, let's take that weight out again. See, taking the weight out again, closing it. Still denser than the air, but now it's not denser than the water. So it floats. The water can support it. It has the pressure to support it. So you get the block falling through the air has more density than the air. So it has a pressure. It's pushing. So the air cannot support it. It gives a force. Pressure is a force exerted. So it exerts a force, and now the water is exerting a force on the block because the block is now less dense than the water. I hope that makes sense. I try to make it as simple as I could for you guys to understand. Hey Adam Meekin, good to see you. Thank you for coming. Tom Budas, thank you for coming, dude. You really rock. And Michael Kahn. Yeah, I'm glad you guys could all make it. Did that explanation demonstration make sense to you guys? Because that's the simplest form of this of relative density disequilibrium. It's so simple. Let's see. So the poll so far on 25 votes. Do you understand relative density disequilibrium? The answer is yes, 44%, no, 48%. Well, it's just changed to 26 votes. So yes, 42%, no, 50%, and almost there, 8%. PJ Krushenk, absolutely. Glad I could explain it in simple terms. Riley was going to get his thesis published in Nature. Yeah, I don't know what happened to that, but I think someone actually intervened with that because, you know, Globe guys love to, how can I say, taint the water for anybody that goes against the narrative. So, yeah. But it was really good on him actually doing hypothesis, experiment, and then trying to publish it. So, yeah. Face Reality, good to see you. Thank you for being here. Another member of the show. You guys are really, really awesome. Thank you again. Hey, Quinlan, 1977. Good to see you. No, buoyant force doesn't exist. Sorry to tell you, buoyant force requires gravity. Gravity doesn't exist. Gravity cannot even be, how can I put it, defined. No one knows what gravity is. And thanks to Craig, by thinking Cavendish experiment, that's actually a demonstration, is a validation of a non-hypothesis for gravity, means acceleration. So when you know that Cavendish demonstration, the acceleration is caused by torque, torque vectoring, then you are actually saying then gravity is torque. So please show me where the torque is when you dropped an object. There's no torque involved. It's simply density disequilibrium, because the denser object relative to the medium gives its direction up or down. If it's denser, the surrounding system cannot support it, hence its pressure is greater, so it has a force pushing through that medium. Or if the medium surrounding it is denser, it will push it up, which supports it because the pressure is greater. Now you get idiots that say, but hang on, why do I have a cup of water and a table? Why is it not falling through the table? That is because you get something that's called a solid. A cup is a solid. There's a difference. A wooden table, is a solid. Do you understand the difference between liquids, gases, and solids? Yes, that's why it's usually considered with fluid dynamics. Obviously, you're not going to have something sinking through a rock, because that's just idiotic. Hi Salted Cedar, good to see you. Thank you for coming in. Really do appreciate you being here. Tom Buddhas, Cavendish hiding from balls hanging in his shed. Real science. Exactly, that's not real science. I'm trying. How can we explain Cavendish? Cavendish is just a belief of correlation. So they take. That's why he just said, I believe because the apple fell, therefore masses attract mass. That is already having a belief that there is a force. We all know gravity is not seen as a force today, so you cannot have acceleration, which debunks F equals ma. Sorry about that, guys, you contradict your own model. So you're either contradicting and saying F equals ma is false, or you're saying you can have a force without, you can have acceleration without any force. So which one is it? You cannot have it both ways. Hey Wynand, Wynand, good to see you. Ek's bly jy is hier so meneer. My kinders is in die kamer. I told them, sorry, you guys can't come in the room today, because every time I have to keep telling them to keep quiet. So no, they're in the room tonight. It's good to see you guys. And it's good to see so much South Africans coming on here as well, because I think I've got like 4 or 5 South African subscribers, believe it or not, which is really awesome. Yeah. So let's get to it. I did show that little demonstration. I think let's get to some more things on the internet, which I think can be quite cool. This was oopsie, sorry. Oh, I don't want to open that. That was a mix-up. Anyway, this is one of my shorts that I had on my channel a while ago. So I just want you guys to listen and try and pay attention. I'm going to let it play through maybe twice or 3 times, just so it can kick into the globe defenders.
Take 2 identically sized rocks. 1 rock from the mantle and 1 rock from the crust. If you decide to weigh both of them, you'd find that the rock from the mantle is actually heavier than the rock from the crust.
Remember, same size, exactly the same size. The one is just denser than the other one, so it weighs more. What does that tell you guys? It's more substance crammed per cube into the system.
Even though both rocks take up the same amount of space, this means that the rock from the mantle is denser than the rock from the crust.
Denser equals weight, guys. You get that? The more mass crammed into the system.
This difference in density causes the crust to float on top of the mantle.
Different in density causes the one to float on top of the other. Why? Because it's denser, it can support it. The pressure mediation is able to support the thing that's less denser. Very simple. Hey, Flat Accord Music, good to see you. Hey, Dalla, Cape Town. Wow, another South African, good to see you, dude. Hopefully in future we can maybe organize some South African flat earth event. I think that'll be quite cool.
To take 2 identically sized rocks, 1 rock from the mantle and one rock from the crust.
Yeah, again, remember, identical rock from the mantle, from the crust. Obviously, it's just hypothetical because the mantle and crust or whatever, but they're trying to make a point of density.
If you decided to weigh both of them, you'd find that the rock from the mantle is actually heavier than the rock from the crust, even though both rocks take up the same amount of space.
Yeah, they take up the same amount of space, but one is denser, which means it weighs more.
This means that the rock from the mantle is denser than the rock from the crust. This difference in density causes the crust to float on top of the mantle.
Very simple. Yeah. Hey, Pumped Laz, good to see you. Remember, guys, mass and density are the same thing. This is them misrepresenting what I'm saying again. Remember, I did say mass and density is the same thing because how I was trying to explain it was, show me density without mass. Show me mass without density. They are intertwined. They make each other. Your weight, I was trying to explain, weight is simply due to density. It's not due to gravity pulling anything. Hence why I just showed you this demonstration. If you missed it, you might have to go back to the beginning of the stream where I do show it. Block, maybe we can show it again. The block is denser than the air, less dense than the water. So what happens when I drop it? Oh shit, it fell through the air because the air cannot support it. But what's the water doing? It's supporting it. The water has more pressure than the block. It's been able to support it. You understand? It's denser. But the air cannot support it because it is denser than the air. Now what happens if I have to make this system denser? Now you ask me, how do you make a system denser? Easy. By adding more substance into the system. In this case, I'm adding some coins. So I've added coins. Now what's going to happen? It is denser than the air, it was already. It's now even more dense. The system will weigh more. It's more dense, so it's going to be denser than the water. Oh, looky there. The water cannot support it. So this has more pressure, because that's what a force is. It creates a pressure force, the pressure mediation. So it causes the pressure which pushes down. That's why it goes downwards. Understand? The water has not got enough pressure to support it. The pressure is greater from the medium that's denser. So that's about it. Sean Hawkins, good to see you. Face Reality, how are you doing? Jolly Man, good to see you. Thank you for coming. And Arkham Virus. Let's see. Arkham Virus says weight due to density doesn't make sense. Yes, it does. Show me having weight without density. Density defines weight. That's how when you take a scale and you have a scale actually measures the pressure pushing on the scale. Remember, gravity is not a force, so it cannot pull anything. Pressure is a force exerted constantly onto a surface. So if we have to take that block again, or even let's just say this charger, I'd say my hand is that scale, I place it down. It is supporting it now. It's the pressure pushing on it that is what's measured on a scale. Now you're asking me, okay, but it's measuring in grams, and yeah, but how that measures is you get what you call a load cell. A load cell will bend inside, taking the strain, so it picks up how much pressure is pushed on that load cell. As the pressure is on the load cell, that's what gives the calculation to be able to work out its weight. Remember, weight is just a measurement. Density determines that weight. That's why you can have a feather that is 10 centimeters and a feather that is 5 centimeters have the same density, because the one, let's say, comes from an ostrich and the one comes from a chicken. If it's more compact, it's denser. But then again, if you drop them, they're not going to fall at the same rate. Why? Because of aerodynamics. That's why they had to remove that for the gravity acceleration. So do we actually see acceleration in reality? Yes, we do. Does it have a Average, yes it does, but it's not caused by a force of gravity, because gravity is not a force. It's simply caused by the density relative to the medium that's out of its equilibrium. Okay, yeah, my umbrella on my patio fell over and broke the light last night. Really? Oh man, I broke last night. That sucks. If that blue block was in the IIS, I think you see it ISS. What the yeah, whatever. It's still more dense than the air it's in, but it wouldn't drop when you look. This is how free fall works. If I'm falling with the system and it's falling with me, remember everything falls relatively at the same average speed. So if you're in a closed compartment like a plane or something and you're free falling, and you have something free falling with it, they are all, everything inside, that's why you find a density tower free falling together with the system. You're moving at the same speed, so it's the same as you standing still. That's why it's called relative. You know, relative, that's why you guys have general relativity, because it's relative to your reference. So you're relative to the reference of the falling plane, hence the vomit comment. If you leave something, it's also still falling, just at the same rate as you. That's why it looks to be staying in the air. It's not, it's literally still falling while you are falling, while the system is falling. Very simple physics, guys. Very simple. That's why you do not get the mixture of the density tower when it's falling, because everything is falling at the same average speed. Star Rock, where does the pressure come from that is pressing down on the block? Very simple. You got air pressure around that's pressing on it. The block itself is denser, so nothing can support it, so it's pressing through the air. That's it. Very simple stuff. Hey, Two Wolves, good to see you. I do have the Discord open if anybody does want to come and discuss with this. For anybody, that's welcome, but I think we're going to maybe go through a very, very cool thing that's got to do, you've probably all seen this before, with Sleeping Warrior. If you guys haven't already, please do go and subscribe to his channel. This is a very so-called famous experiment he did, and yes, this is an experiment, guys, because it has an actual hypothesis and experiment to validate it. Let's go through it.
Here's a fun question for Riley. What's denser, an egg or water?
As like he's trying to have a got you.
If all that matters is relative density, then the egg should sink.
Is that so? Take it away, Riley.
Funny you should ask that question. Today's video will be doing a little bit of science, and we will be observing how we can manipulate the medium by changing the density and create a force.
Did you guys hear that? He's manipulating the medium to create a force, which is what? Pressure. Something gravity doesn't have, remember, so gravity cannot cause acceleration.
Newton said, where there is an acceleration, a force must be present. Today's video is all about science. But first, some context from a science denier with a counter to my claims from a recent video of mine. The self-proclaimed physics degree undergraduate makes a claim and gets it totally wrong. Let's consider his words carefully. This guy claims to be a man of science but doesn't know what the cause is in an experiment.
Don't we see that a lot though, Riley? I mean, look, I got a so-called FTFE saying he was a nuclear physicist for the Navy, and yet he doesn't even know how IV and DV works. He doesn't know how to set up a hypothesis. He thinks you can have more than one cause in the same experiment and hypothesis. He thinks time is an independent variable, and he thinks weighting actually manipulates something. So it's kind of well known that it's pseudoscientists that don't understand how an experiment or hypothesis works.
Neither does Geo Whisperer. Quality between the density of the egg equal to the density of the medium it's in. But what Nora says is, he equates cause with that which one manipulates. Well, your independent variable is the variable that is manipulated by the researcher in an experiment.
Yeah, so if you don't manipulate what you presume to be the cause, how are you going to know it's the cause of the observed phenomena? Very simple logic.
It is the presumed cause.
Stop. The reason he's talking about this again is because he hasn't mentioned it here, but I think in this experiment, this video, they actually poured the salt in. So I think he's claiming you can change the density of the medium, and therefore that is the cause, or his independent variable is how much salt you poured in. He hasn't mentioned this, of course, but I think that's actually what he's trying to get at. I mean, I know it seems insane what he's saying here about you have the control over the density, and but he actually means that that's because he's been pouring salt into it or not.
Yes, making the water more saline or salty, you change the density. That's the medium. He's manipulating the IV to cause the DV. Very simple stuff.
Yeah, exactly. You obviously do have the control over the density, but where's the connection from that to density is the force?
Where's the connection? Acceleration. My man, there's acceleration. So remember, F equals ma. Acceleration requires a force. And what did we know? Gravity is known not as a force. So you know that F equals ma debunks the globe, because gravity is not a force. And you require force to have acceleration. Nice thing about relative density disequilibrium, there's a force present. It's called pressure.
Yeah, I mean,
There's
exactly.
no causal relation there.
Exactly, he's just gone off wildly into this quantum eraser dogma land where they prefer to live, about independent dependent variables, and so he's just trying to prove forces because there's an effect as a result of changing the independent variable, i.e. the thing that is the cause in his mind.
No, it is the cause. Remember, science works with causation, not correlation. Yeah, this is why you don't see Rumpus around anymore, because that guy is one of the most... Yeah, I'm not even going to say the word.
Although, of course, he doesn't like the idea of any cause has more than one factor, because, of course, you've got the density of the liquid, you've got the force of gravity. In other words, there are multiple factors, and he can't cope with that. Like, Nathan doesn't understand that an effect is the result of more than one factor.
No, Rumpus. When you make an hypothesis, you have a single cause for an effect. That's why your hypothesis works with an IV, which is singular, not plural, to get the effect. Singular, not plural. If you want to have another hypothesis trying to work out the same effect, you create another hypothesis. Hence with the boiling water. Heat energy causes water to boil. You can test it, it validates, voila. But your control was 1 atmospheric pressure. What happens now when you do another one? Because you can see there's another cause for the same effect. Now you have another hypothesis. Pressure differential causes water to boil. So you do that now. Does it invalidate the previous hypothesis? No, it doesn't. It's validated because heat energy will always cause it to boil. Just like changing air pressure will always cause water to boil. There's reasons for this. But there are two separate hypotheses with two separate experiments. You cannot intertwine them and make the same, because once an a hypothesis is validated, it's always proven.
Yeah,
So
apparently he doesn't understand that an equation can contain more than two factors.
Yes, more.
Yes, more than two factors, but if your hypothesis states the cause for the effect, that is the cause for the effect. You're not testing some other cause for the effect if your hypothesis says this is the cause. When you've done the hypothesis, done the experiment, done your predictions, and go on, you create a new hypothesis with the new cause. Capish?
More than one factor, no?
Well, yeah, more than one factor, actually, yeah.
Yeah, exactly right.
So we've got his words. We'll come back to them in a minute. It's clear that we need a definition or two for the rumpus. Let's not cherry pick one. Let's go with, say, 10. And let's...
Yeah, I do know the Globus did not like these definitions, so just sit back and enjoy, guys.
see if there's a common theme for what is an independent variable. We're looking for what it is and the effect that it has on an experiment. Let's see whether his words were correct.
from Colorado Science and Engineering Fair, the independent variable is the variable which an experimenter deliberately manipulates in an experiment.
From Penn State University, there should be 3 types of variables in every experiment: the dependent, independent, and the controlled. The independent variable is what is varied during the experiment. It is what the investigator thinks will affect the dependent variable.
Do you guys see any independent variables here, or is it just independent variable? Remember, plural.
From explorable.com, the
singular.
independent variable. This is what you change in order to provide a result. The dependent variable, this is what you are measuring.
From award-winning awardco.com, an independent variable is the variable that is changed or controlled in a scientific experiment to test the effects on a dependent variable.
I think we're getting the gist here. It's a singular cause for the effect.
From the University of North Carolina. In an experiment, the independent variable is the variable that is varied or manipulated by the researcher, and the dependent variable is the response that is measured. An independent variable is the presumed cause, and the dependent variable is the presumed effect. In experiments, the independent variable is the variable that is controlled and manipulated by the experimenter, whereas the dependent variable is not manipulated. Instead, the dependent variable is observed or measured for variation as a presumed result of the variation in the
I just have to go back to this one little section here because it didn't read. The IV is the antecedent, whereas the DV is the consequent. You understand? The cause for the effect. If you do not have the cause, you won't have the effect. You know, like gas pressure requires containment. The antecedent would be containment, because pressure is a force exerted on a container wall. You get? Antecedent, consequent. Antecedent, consequent. So every time you know you have the consequent, it requires the antecedent. Get it? If you see water boiling, you know heat was added. You know there's temperature. You know there's some kind of energy transference. If you see gas pressure, you know there's containment, because without it, it cannot exist. Hence, the effect is dependent on the IV, the cause.
Result of the variation in the independent variable.
According to the GCSE citation in experiments, variables are used to help determine the cause and the effect. An independent variable can be thought of as the cause of change. A dependent variable is what is affected by the independent variable.
Yep.
There can only be one independent variable and one dependent variable in an experiment.
Craig, remember I said just find one? There's one for you. They all actually said that, but this one specifically says there can only be one. What are your thoughts now, Fight Flat Earth?
Everything else that can impact the experiment must be kept constant or controlled. These are known as controls.
Oh, and do note, FTFE, because you want always educational citations. What is this? It's an edu site. Uh-oh.
The independent variable is controlled by you. In other words, you can manipulate the independent variable during an experiment to discover what effect it has on the other variables. This is the cause.
Yep.
From practicalphysics.org. That's the Institute of Physics. The independent variable is the variable that is deliberately changed by the experimenter. The dependent variable, an outcome variable that is measured each time the independent variable is changed.
From the University of Southern California, the dependent variable is the presumed effect. The independent variable is systematically manipulated by the investigator. It is the presumed cause.
Is the presumed cause. And by the way, guys, do subscribe to Owen. He has an awesome channel. Definitely worth the while to go and listen to him. He has some awesome chats. I think he does a daily show. So, yeah. Keep it up, Owen. Really do enjoy your content.
From Indiana University. Independent variables are felt to cause some change in the dependent variables. They are manipulated by the researcher. Dependent variables are felt to be affected by independent variables. They are measured by the experimenter and are normally responses of the subjects.
By sciencing.com, the independent variable is the variable that the scientist changes during the experiment. Think of the experiment as a cause and effect exercise. The independent variable is the cause factor.
Okay, before we go on, let's see how it's going on with the chats. I see a lot of buttered globers here. Yeah, guys, Owen, if you can, just put your link in the description for the guys, and they can all go, hey, Sargon, what? Saigonustap or whatever your name is. Hey, Charlie Walsh, good to see you. Starrock. That's what's perspective. Where does the pressure come from that is pressing down the air pressure, pressing down? Pressure, what do you mean where does the pressure? It comes from the density. It's physical. Like this cup, it's physical. Air is hitting it, that's pressure. The cup is pressing on the air constantly, that's a pressure. So if the air cannot support the cup anymore, the pressure is too great, so it accelerates because of this pressure. Understand? Pressure requires force. Acceleration, force. Pressure, it's pressing through the medium. Very simple. Yeah, 100% agree. Owen's channel is ace. Who's what? Antecedent equivalent collection. Good to see you. Who? Owen? That's right. I have to continue my Dasha. I might sub. Yeah, do sub to him. Hey, Rachie. 50 is good to see you. Thank you for coming. Exactly. Relative density is. It's the one I'm thinking of kind of debunks consensus claims. Exactly. Relative density disequilibrium can be scientifically validated. It has actually been, and it's as simple as you create the hypothesis. I mean, what was my hypothesis for the demonstration I showed? Well, it was actually experiment, because I changed the density of the system. I created the system to make it more denser, which gave it more weight. Obviously, density per cube doesn't change, because that plastic is always going to have the same dense per cube. The same with the coins that I put in, it's going to have the same. But the system itself, if I put it into the same system, it made the object denser, which gave it more weight. The weight is just a measurement of the density pressure. You get that? Very simple. So, hypothesis, the density causes acceleration through the medium. So what happened? I changed the density of the system, it caused acceleration through the medium, therefore it was validated. It showed it had a force which was attributed because of acceleration, which goes against gravity because gravity doesn't have a force. So gravity either has to ignore F equals ma, or F equals ma is wrong according to gravity, because you require a force to have acceleration. Relative density disequilibrium does have a force, it's called pressure. So next time someone comes and tells you, but how does relative density disequilibrium have force? Easy, the keyword here is pressure. And then they're going to get to, but why is it not going up when you pick it up? Because you're picking it up and you're creating energy into the system. It literally takes energy to pick something up. If you let it go, do you think it's going to have more energy going up? No, it has to release the energy because it has to turn to kinetic energy, and therefore seeking its relative equilibrium point. If it's denser than the medium, it will go to that. If it's going to hit onto a solid, the solid will support it because the pressure of the solid supporting it is dispersed along, and hence Archimedes' principle, but it's a solid, so it cannot go anywhere anyway. So it's very simple stuff, guys. Okay, I think let's carry on with the video. Make sure it's showing. Yes, it is. Hope you guys are enjoying this so far.
FE is getting the message. The independent variable must be manipulated. It is the presumed cause. There can only be one independent variable. This is science.
100%, Anthony. One independent variable. That's science. If you say two independent variables, then you are pseudoscientist. You are claiming science based on correlation, not causation. Hence, gravity is not scientific.
It's really worth being aware of what it doesn't say is science. It does not say that you can infer additional causes.
Ouch.
You cannot substitute in or introduce or suggest alternative causes. That would fall outside scientific method because there's no citations that allow you to do it.
Yep, because then it's correlation based and not causative.
We need a quick position with regards to what is inferred cause. From the University of British Columbia, Richard Johns writes, before we can discuss inference to the best explanation, we must be clear on what an explanation is. That involves the notion of causation and also of inference. There is an important difference between physical causation and rational inference.
I hope you're paying attention to this, FTFE. I hope you're paying attention.
Tim Osman calls this logic and reason. Causation is a physical process that happens in the real world, whereas inference is a mental process that occurs in the mind of a rumpus or a geostrieber. There is a big difference between saying the physical event, the egg physically moves, or changing the density of the medium produced the egg moving, and knowing that an event or a gravitational force exists, that I can infer that that caused the movement.
Yeah, that means it's correlation based on a belief which is pseudoscientific, because you're already assuming gravity to be a force which is not a force, so it cannot cause an acceleration. Hence, you cannot claim gravity because it literally shows a force present. Thanks, relative density disequilibrium, for showing you have a force that causes the acceleration. So what is more logical, to accept something that doesn't have a force which goes against F equals ma, or something that does have a force that can be tested over and over, that shows reality, that can be validated and, well, yeah, demonstrated over and over? I don't know how much more clearer we can make it.
There is a big difference between the two. Surprisingly, perhaps one of the most common confusions in thinking about causation, or even among philosophers, in this case Rumpus, is to get mixed up with the inference. Do not make this mistake. Talking about you, Rumpus.
You should actually try and cut that out, say not just Rumpus, all the globe defenders, because they all fall for the same problem, Riley. So we might have to update this.
One finds in this subject a kind of demonstration which does not carry with it such a high degree of certainty as that employed in geometry, and which differs distinctly from the method employed by geometers in that they prove their propositions by well-established and incontrovertible principles.
Oh, look at that word prove, guys. They prove their positions. That's a word that these guys don't like. Remember, science doesn't prove things. But then you go and look what validation means, and you look what fact means, what evidence means. Yeah, and how can you disprove something without proving something? You have to know it's got antithesis. That's why when you create a hypothesis, you have a null hypothesis, because you're either proving the one and disproving the other. It's the consequence of the other. That's why it's called a logical inference. It's based on logic. That's what a scientific method is. It's got nothing to do with one's subjectivity. It's got nothing to do with your opinion. You get it? So, what am I saying? Subjectivity, but it's got nothing to do with your opinion. Simple as that.
Whilst here, principles are tested by the inference which are derivable from them. The nature of the subject, light, permits no other treatment. Well, thankfully in scientific method we do have other treatment. It's called scientific method. Ooh. So it's only where you do not have any other treatment can you infer cause. But thankfully we do. We have scientific method.
Here comes the experiment, guys. Remember, pay attention what the hypothesis is and the experiment.
This is an egg.
That's an egg, guys.
This is a parts per million counter. Inspired by Jaron's most recent video. If you haven't checked it out, go to his channel, and it's called something like How and Why I Drink Distilled Water. He used one of these and he measured the amount of particulates per million in his tap water. I decided that I could apply what he used, this little bit of technology, not science, this is technology.
Yes, remember, technology comes from science, but it isn't science. It's called logical inference based on what you established in the science.
I could apply this technology and I could perform a practical scientific experiment where I could measure the density of a medium, in this case water, and I can make this egg move.
So in other words, causing the medium's density to change would cause what effect? It would cause the egg to accelerate. So changing the medium's density causes the egg to accelerate.
All by itself, with just a little bit of salt. I can observe my phenomena to be that some objects appear to float, some objects appear to sink, some objects will suspend in different mediums. My hypothesis is if I change the medium's density, the egg will move. Newton said, if an object moves, a force is present.
Remember that? F equals ma. Thank you, Newton.
My null hypothesis is that if I change the density of the medium, the egg will not move.
As simple as that. And we couldn't even get Craig to give a simple hypothesis like that because he gives no hypothesis. He gives more than one cause.
I will activate one of the hypotheses. My independent variable, my presumed cause that I must manipulate in an experiment, is the density of the medium. My dependent variable is the movement of the egg. I will also try and keep everything else constant. The volumes of water, not no change, just the density of the medium.
Get it? Changing just the density of the medium. That is the cause for the effect.
Let's see how I'm going to do this.
Yeah, let's go ahead.
This is my egg. This is my parts per million counter. This is going to measure the parts per million of both these fluids. This is tap water, regular tap water.
Yeah, normal tap water, guys. H2O. Still got all its properties and everything. You can drink it.
That is the same tap water, but it's been preloaded to save some time with some salt from this to give it a density variation. It's going to measure the density of the tap water. So while it settles down, it takes a little bit of time. Okay, that's coming in at 212 parts per million tap water. Don't know what that means. It's just a number. It could be unicorn farts. It's just a tap. It's just a number. So 212.
Sorry guys, just give me 2 seconds.
12 is the recorded density of this one. Mind you, I should have showed that to the camera, shouldn't I? It's going in at 214 now. So if you want to zoom in on that, it says 214 parts per million. Okay. Back to 0. When I do it to this one is saying this is 302 parts per million. Again, if you want to zoom into that, you can have a look.
Very simple, the parts per million has changed.
Okay, so basically 200 to 300. Let's try this one again.
Look at that seriousness on his face.
208. Yeah, it's about 200. Then.
Why aren't you guys listening to him though? I mean, he's got a white lab coat on, he's got glasses on, he said the word hypothesis and science. So, you know, that's the only standard you guys have for science today. A guy wears a white lab coat and he says science and hypothesis and you think it's science. So you should be listening to him. Just had to point that out to the globe, guys.
This one's about 300. Yeah, so it's 200 and 300, right? So one's got 100 more parts per million than the other. That tells me that there is a density variation between the two. So what we're going to do is we're going to see what happens when this egg is dropped into here.
What are we seeing? That egg is denser than the water, so it is going where? To the bottom, because the egg's pressure is obviously pressing more than the water. The water is not able to support it.
It sinks and it's touching the floor. Let's take the egg out. Now we'll see what happens when we put it into a more dense medium.
Uh-oh! What's happening there? Why is it floating, guys? Remember, in the other glass that wasn't as dense, it went to the bottom. Now it's able to support it. It's got pressure mediation against the egg. In other words, it's got a force. Force causes acceleration. Without the force, you cannot have acceleration. Therefore, the pressure is the force. Thanks to density.
So whilst I was settling down, this was done last night because it takes ages for it to dissolve and it get to a point where it's saturated. And I've got some residue at the bottom that is salt. So at the bottom at least, it's getting relatively saturated. So I'm going to give it a stir to stir it up so that it evenly distributes a little bit better. Because what I'm hoping to do is get the egg so that it's just sat above the bottom of the thing. Some people will argue and complain and say that I shouldn't have stirred it, I should have left it as a gradient. It doesn't really matter. Because what we're trying to establish is, if the medium is different, does it make a displacement?
Yes, and you have proven that. He proved his hypothesis. He validated it. Very simple stuff.
Does it force a displacement? If it forces a displacement, according to Newton, there is force. This is just normal table salt from your favourite supermarket. Other supermarkets are available. We can tell that the density of the egg is equal to the part in the glass where the liquid is. What I'm now going to try and prove is that if I change the density of the medium, I will cause the effect by adding salt.
Remember, he's actually already validated, he's proven it. But now he's going to prove it again. He's going to cause the water to be more denser, and therefore it's going to cause an acceleration. Acceleration due to cause and effect. The density causes the acceleration effect.
So if I can change it, because I'm the experimenter, and I'm manipulating my presumed cause, my independent variable is the medium, that egg moves, I've caused it. We know the parts per million is about 300. All we need to do is pour some of this in. Hey, what do you know? The eggs immediately moved. Didn't have to wait for that, did we? So, what's the explanation? Well, I'm going to measure this now. This isn't going to be much more above 300.
Obviously it won't be much more because it hasn't got into the system yet. But you get the gist of it. Very simple stuff, guys. Gary Wybenga, good to see you. Thank you for coming in. Theta Paradigm, good to see you. We did floaty things when I was 5. I blame them teachers. Yeah, we did floaty things when we were children. It's a shame that we have to still teach this to grown-ups today. Hey, Mr. Schooler, good to see you. Thank you for coming. Really, really do appreciate you being in here. How you doing? Yeah, so if anybody actually wants to come into Discord, you're more than welcome so we can have a chat. Hey, Brian Leake, I see you in Discord. How are you doing, mister?
I'm doing good, man. How are you doing?
Doing great. It's nice and hot here tonight, I must say.
Yeah, looking at the experiments and everything, I don't see how they could really argue with that. My question would be, also I've been saying too, for quite a while that when I argue with Globers, that you're adding the energy when you move something. Like everything, when you walk outside, everything is pretty much where it is naturally, equilibrium, and you can't move anything without adding energy up or down, and so I try and get them to, they bend over backwards trying to come up with a way something moves without adding energy, but they say like undermining something, digging like underneath, and I'm like, you still added energy digging underneath it. There's really no getting around that. But I would say this, in all fairness, I would say, could there be other causes, for things moving, or things falling, or things rising, and that's where the others. I don't necessarily go with dielectric acceleration. I can't really get fully on board with that. But as far as orientation, I could buy that. Because to me it seems like up is different from down. Up is
it's a relative
definitely
position.
different from down, and so I think I've formulated a potential experiment to run by you.
Okay.
You tell me what you think.
Okay.
Okay, so we could pick the natural phenomenon. We could pick from a few, and that would be like spider ballooning, or the pollen harvesting with the bees, where they showed it in slow motion, where the bees get close to it, and the pollen comes up to their legs, or I could use what else could I use? Or just something falling, whatever. But and I could say that's the dependent variable. Independent variable. Now this doesn't do away with Anthony's experiment at all. It's just like a supplementary cause that I'm
they're trying to work on. Yeah. But that's why I said you can have more than one, like the boiling water I was saying, you can have more than one cause for the same effect. That's why you have two different hypotheses. Doesn't make the one invalid. It just shows you can also have the same cause for an effect.
Right. And this, to me, like I said, this is just a start. This would be, to me, like for orientation. So the independent variable would be electrical gradient, electrical or static electricity. Let's say that. We can elaborate on it, but we'll just for rough causes, just for now, we'll say static electricity would be the cause of orientation or directionality.
Okay.
So and then we set up. So the hypothesis would be that the field, the change in static electricity will cause objects to rise. Or I'm trying to think of a way to put it in the hypothesis, but something like that. Something like the static electricity will, if we change the vector in the electric field, or the static electric field, then we change objects can accelerate up or just move up, and it doesn't even have to be acceleration.
So
and
you're
then
saying if
we reverse the static field and the null, if we reverse the static field, objects won't go up, something like that.
Oh, so you
should have wrote this down.
Okay, so you're just trying to say then the cause would be if you induce a static field, then it will cause acceleration.
Sure. Well, if we, that's not really. That's kind of one way to put it, man. God, I wish I'd have wrote this down, because a few of us in Earth Awakening were just we're brainstorming it, seeing if we could formulate it into a
Look, I think
experiment.
the best would be, because hypothesis be kind of very systematic. So maybe you're gonna have to sit back and just try and word it better, so you can make it more clear what the IV would be, and then you can come present it again, and we can actually look at it that way. I think that would be quite cool.
And here would be the thick of it. If I can remember how we worded it, or go back and listen to it. So it was worth running by the guys and seeing what they say as far as it being valid, and it was a observed natural cause. But so the thing was to reverse the static field, the natural static field, with of course the Vanagrap generator, and it can overcome relative density, basically. Not on a large scale, but if we reverse the polarity, then that, like the iron filings, the wood, any small objects will go up.
What do you do with? But what do you do with a dielectric? What do you do with the diamagnetic problems though? Because there's substances in life that is diamagnetic, so it has a negative repulsion, so that goes against the two Gaussian plates to give that static rise, you would say.
Yeah. Well, I don't know about the dielectric, and I'm not speaking toward the dielectric acceleration. I'm just speaking like toward the orientation.
Yeah.
And it doesn't seem like a lot. It doesn't seem like a lot, right? As far as it's a lot of volts. It's not much current, so it's not like a lot, but it's a lot of volts to get something to overcome the relative density. But it can, it could be a factor because it does. If you put them in the generator. I watched Brian's video, and he was talking about levitation in the Vanagrap generator, and that's one thing he was not quite on target because it doesn't levitate. It goes to the top plate if you reverse the polarity. And what they say is that like the iron filing, if you scaled it, it would be bigger than Mount Everest. It'd be like 10 Mount Everest compared to the
but the
size
problem
of
with
the Earth
that
and all
is
that.
you do understand that the Vanagrap generator requires induction. You have to literally induce the field to happen. This doesn't happen in nature though.
Mm-hmm.
It's not self-induced. It's man-made.
No. Well, it's got to. The experiment has to be manipulated with man-made.
But I'm saying you don't observe this in nature though. You're literally inducing.
The dependent variable has to be observed in nature.
Yeah, but where are we observing things floating in nature though? Caused by static electricity.
Like I said, spider ballooning, because we know the spiders are denser than the spiders are denser.
Yeah, but it's pressure.
In the air.
That's pressure. It's not due to static. The pressure from the spider ballooning causes it to pick up by the wind. It's like a guy jumping out of the airplane with a parachute that picks up air in the parachute. That's what spider ballooning does.
What? What'd you say?
When the spiders do spider ballooning, doesn't it go hundreds of kilometers away? But how does it do that spider ballooning? It's picking up the air around it. That's what's pulling it around. It's not the static pulling it around. It's picking up the pressure from the air.
Yeah, but it rises due to
pressure.
I thought that hold on. Maybe I'm wrong, but I thought that they shoot their web up and they rub their legs or some shit, dude. They induce like a charge or some like static electricity in the strand that they and the strand literally carries them. So as they're floating along, maybe the wind might carry them, but they overcome the downward bias or the downward whatever you want to call it due to the static. That's what makes it float. That's what I thought anyway. If wrong, I'm wrong.
I'm gonna try and see if we can find something because as far as I know, it's the pressure that picks it up, not the static. So I'm just gonna quickly look on the internet because it is quite interesting. See, they do shoot it up in the sky. Spiders use silk to catch prey and to anchor themselves against falling, but spiders also use their silk to fly. Spiders fly by a process called ballooning. It's the young spiders that usually balloon chiefly to disperse after hatching. Ballooning is possible for a young spider because it's extra lightweight. You see, it's already denser. Less denser because it's lightweight. That's why the young spiders do it. Uses to take flight. A spider must catch a breeze. So you see, it's catching a breeze. It's catching the wind. So it's pressure.
Yeah, the flat air currents, aren't the convection?
Yeah, that's what I'm saying. It's because of the pressure. It's not got to do anything with electrostatics.
What did it say? But well, I'd still say the spider, even the young ones, are relative density is obviously what's causing shit. The medium.
But
I was just thinking like I was just thinking of for an orientation, like is what I was trying to think in terms of. But I'd still say the spider, even the small ones, are more dense than the air, though. Would think, but probably not by much.
Yeah, but that's what I'm saying. The density is what causes the up or down motion because it's less. Remember, the new spiders is less denser, so it's easier for the silk to catch the wind, and that's what's causing it to actually lift up. It's not electrostatics.
Okay.
I have heard Globusters try and claim this before, but I haven't seen anything actually show it's due to electrostatics. That's what I'm just trying to say. I'm just trying to bring my side to it.
Yeah, I understand. Yeah.
I'm not saying.
Hey, I got it. I know Flatzoid. I know what it is, Flatzoid. The little spiders, they're taking a big old breath of hot air, man. And,
it's just something really. I think I'm going to look more into this as well. I think it's quite interesting. But if I look at it, it just shows relative density. What we observe.
Right.
Yeah.
To me, I've always stood behind the argument of relative density disequilibrium. But for me, there's obviously a difference between up and down. And for me, it's worth looking into. It's worth seeing if we can formulate something for orientation. You know, whether it be electrostatic, whether it be whatever. You know, I don't believe in the gravity downward force 9.8 meters per second. You know, there's a million things wrong with that, and plus it's not even a cause. It's like the cause and the effect. Like if mass, then mass attract mass BS. I mean, they don't know where to go with that one. But like I said, to me, there is an orientation, a natural orientation. Maybe we'll never know.
Yeah.
Maybe we will.
It's
That's
just
what
another avenue
talking
to
about,
look down.
right?
Yeah, it's just another avenue to look down. Definitely. But it's interesting. Like I said,
any guys listening from Earth Awakenings, I think Jeremy was in there. I think Austin was in there, and Percentage, and a lot of us men. We're just brainstorming, seeing if we could formulate it into a legitimate hypothesis.
Yeah.
And we come up with something, man. I murdered it and really butchered it. But we come up with something to run by y'all, man. And they're probably punching their screens right now the way I butchered it. But
no, man. Like I said,
I think the natural phenomenon might have been the pollen up harvesting or whatever. Like I think they've showed that the bees, like the pollen, when they fly over the pollen.
Oh, because
the
static
flower,
with their wings.
like the pollen kind of rises up off the piston or whatever you call it, and up to the legs.
Of their wings.
I think they've recorded that, but I'm still not sure what caused that. To me, it'd have to be electrostatics or something similar, but I don't even know if that qualifies. But just running it by you.
I think it's going to be best maybe to go and brainstorm again and try and work out a more coherent, explanation of a hypothesis. You can even get these guys to come in as well. It will be quite interesting to actually talk about this. Because I'm interested to know what would be the cause for that as well. So, yeah, if we can get them in sometime, we got cool.
Yeah, maybe one of them's listening, man, and they could join and refresh my memory, or we come up with something that was worth a discussion, you know.
Yeah, definitely.
And I wish I'd have wrote it down. But I did not.
But thanks for bringing it. Like I said, everybody has their different takes and stuff, and I respect everybody's takes on reality. So, definitely, I think maybe work on it a bit more and get everybody together. Maybe it will just make more sense if it's said differently. I don't know.
The guy come in Earth Awakenings last week, and he was, I forgot what day it was, but I think his name was man, I'll remember his name in a minute, but he was smart, and he had degrees and all that, and he was arguing for the mathematics for just the density of the fluid medium, you know.
Yeah.
And he, you know, because mass cancels, and the you know, M1, M2, they cancel, and you know, I think other people have seen that video where it might be the same guy, but he shows that, you know, just by dropping something and measuring, you could do the math, and without gravity,
you don't need gravity.
measure the acceleration.
Yeah,
with
you don't
just
need gravity.
the object and the height.
But that's what I'm trying to explain to the globe guys. Just because they place gravity into the equation, into their math, does not make gravity real. It's simply them reifying their religious beliefs into reality. I mean, you can debunk reality of maths just by picking up an ice pack, like I did when I debated FTFE the first time. I showed him I had one ice pack. In maths, I can make it 5, but not in reality. Just because it works on the math doesn't mean it's reality. And that's exactly what they do with the whole globe model. Everything, gravity is just based on that. They have an equation with the belief gravity exists, but it also goes against Newton's laws of motion. So they contradict themselves, but still hold true to the law of gravity, you could say, but it doesn't exist.
Yeah, and they give it to Newton, right? They attribute it to Newton's law, and then they say that Cavendish is the one who got big G, and then the Cavendish experiment, he was supposedly trying to measure the density or the mass
the density
of Earth. And here's the problem with that. Okay, you can't get the mass without the density, and you can't get the density without the mass. I mean, the way they did it, basically, it's almost obvious to me that they had a number, because like I said, mass, cancels itself out in the mathematics. So to me, they had a number already in mind. And, or why would they attribute that to Newton if he didn't even have nothing to do with it, basically? I think they had a number in mind, and they came up with it, basically. Whatever's causing the attraction, I think to me, they already had a number in mind. But it is, pretty coincidental.
But you do know Cavendish is
I don't know, man. I don't know. I can't buy just gravity. Just calling the time in the fall and then naming it gravity without any proof, and then attributing it to the bending of space-time. That's a cop-out to me.
The problem is when they try and use Cavendish to validate their so-called attraction of gravity, they are just conceding then that it's torque, because that's what Cavendish is. It's simply the torque measured. So is gravity acceleration now torque? Because that's all Cavendish is, it's torque. They're measuring torsion twist caused by torque. So when you have torque and you're saying Cavendish is validating gravity, you are saying gravity is torque. So where is torque when I'm picking something up and letting it fall to the ground?
Good point. But I'll say this, like the Cavendish setup is supposed to be so freaking so sensitive. They say that we can't feel Earth's acceleration, barely. Like it's not quite fast enough for humans to perceive it. But this setup that's so sensitive doing that spark, how could it possibly sit still if it's that sensitive to movement? And they'd say the Earth's moving. To me, that's a contradiction.
Yeah, 100%. But then again, everything that they say is a contradiction. I mean, even the Cavendish itself is very unreliable. People get different results all the time. Some people don't get any results. I mean, I've even seen when it goes the opposite way of putting the masses. So, really, it's actually sad.
Yeah, I had Blue, man. I mean, he had an explanation, but I recorded Blue and put it in an old video where he said at one point, I absolutely proved that mass repels mass, but this was before he put up the static fielding and all that stuff. Like I'm not going to dog him out. He ain't here to defend himself, but I'm not going to completely dog him out. But I thought it was funny that he said that. And to me, what was funny that I've told him 1,000 times that everything that went wrong, he attributed to electrostatics. Like when it went the wrong way, electrostatics. When it stalled, electrostatics, And then when everything was set up just right with the right tension wires and the right foil and the right grounded right, then all of a sudden it's gravity. So it's electrostatics. He's manipulating the whole way there, and then when he gets it just right, it's gravity. That was crazy.
But the problem with that is as well, he's manipulating more than one variable, so it's correlation based. That's also what I try to explain to FTFE. When you are manipulating distance and mass, it's more than one variable. It's correlation based. It's not causative, so it's not an experiment. It's not scientific.
Right, man. Right. Man, I wish I could remember. I wish somebody would join. I know one of them guys got to be listening who remembers that. No, but if none of them join, I'll go back and listen to it and bring it up next time. And,
yeah, definitely.
And it was decent, man. It wasn't, didn't seem perfect, but it was a foundation to work with. To me, it might have shown orientation, man. I'm not, as far as the acceleration, man, I think we've already got the cause for that. But orientation, man, I think that might be something we can we can add to it, maybe. Worth a try, in my opinion.
Density disequilibrium does give the orientation. That's what I'm trying to explain. If it's denser, down. Less dense, up. There's the orientation. You don't need electrostatics for that. It's simply the pressure.
No, you don't. You don't need electrostatics. No, even if it is something else. Like it could be frequency. Like I showed a video of a aquarium, and they blow air in it once they get it to a certain frequency, shaking, vibrating, and they blow air in it. Instead of air floating to the top, the air literally stays at the bottom, and it's shaking so fast you can't even hardly see it shaking, you know?
Yeah.
And so it just looks like just air sitting underneath. And in this small aquarium, they take a boat and they put it upside down on the water. It literally floats on the water upside down.
Yeah, because of frequency.
Then they pull it down to the air at the bottom and let go, and it rises back to the top and floats on the water upside down. So I'm just saying, it doesn't necessarily have to be electrostatics. To me, that's the prime candidate, in my opinion.
Yeah, the pressure.
It's obviously around us, but something, you know, to me, something is, yeah, obviously if something's denser, it's going to go down. If something's less dense, it's going to go up. But I'm just trying to see if I can figure out anything that makes it that way.
That frequency changes the pressure mediation, and that's why it can do those things. At the end of the day, we live in a pressure world. Everything consists of pressure. There's not one thing that's physical that does not have pressure. Density is simply the pressure of the system. That's it. So if you're going to change the pressure, you're going to change its behavior, which is changing the density. So if they have frequency changes, let's say that's why you can have little water droplets floating around, look like it's levitating, because of the frequency around it, which is causing pressure against it. And that's why it looks like it's floating. Obviously it is, because the pressure is literally pushing against it, holding it in that position.
Yeah. I'll say this though, being able to overcome relative density by reversing the static electric field and make things heavier or whatever, but that's food for thought. To me, that's worth looking into. It's worth talking about whether we can get to the bottom of it or not. That just seeing that was pretty intriguing, man. But as far as if I'm in any arguments or debates with ballers, I'm not going to go there yet.
Yeah.
You know? But I do like to talk about it, and
awesome.
I like to keep open minded if somebody. But here's the one thing. So you would agree that up and down are different, though, right?
Yeah, they're relative to the density. That's what I say. You definitely have an up direction and a down direction. There's no doubt about that. That's why you stand on your feet and not your head.
Right. Yeah, so that's pretty much where I stand. Like okay, I'm not gonna deny the obvious, but yeah, as far as the causing and all that, that's a different story.
Yeah.
So that's where I'm at right now, as far as my truly, honestly. But like I think there could be something there, so I'm gonna look into it some more.
Yeah, but like I said,
could be a dead end. Could be a dead end. Could be something there, man. We seem to have come upon something, man.
But I'm saying it's worth a chat. It doesn't help just if someone doesn't agree with something just to throw it away. So I definitely would be interested to have a chat. If you can get them all together, we can have a chat sometime. It'd be awesome.
Hey, I'll try to set that up, Flatoid. I'll definitely try to set that up. Yeah. And here's the thing. So any of them that I have heard talking about this, and when I've been in conversations with them, and I like to argue, and I like to argue either side sometimes. But nobody denies, that's the good thing, is nobody denies that the main cause of everything, you know, if not the only, but is the medium, is relative density disequilibrium. That's obviously the foremost prevailing cause for sure. You know, that's you know, Anthony's experiment, or you know, if not even before he did it, we all knew that. Yeah. That just was icing on the cake.
Definitely. Yeah. I just hope I try to explain relative density disequilibrium in a simple way that people can understand it. That's the whole point of tonight. Because I still get people asking, why is it not going up if there is less denser above it? And it's so simple, because you're literally putting energy into the system when you pick it up. If you let it go, if you want it to go up, it means it needs to add more energy, because you've taken it out of its relative equilibrium point. So you've stored potential energy into it. When you've let it go, it turns to kinetic energy. And no, you do not need gravitational pull to have potential energy. That's just put into the equation because of the belief of gravity. There's nothing pulling it down. It's simply the pressure caused by the dense object which gives it the force, the acceleration.
One thing I'm absolutely sure of is that space-time bending, so this whatever medium bending is not the cause of anything. And I'll say this, like when I'm debating with them, they like to, like the Glovers like to argue about dropping things. And I'm like, no. If we're gonna do this experiment, let's do it right. So let's walk outside and start from there. Don't pick something up and then, and lift it up to a platform and then try and start the experiment, because you've already added energy. I told them, when you walk outside, nothing's really moving. It's going to take energy even to blow a leaf off a tree or something, man. You're not going to move. Everything's in balance. Everything's in harmony. I'm outside right now, and nothing's moving, man. Except I see a bird flying way off in the distance.
Let's say an apple, when it grows with the tree. From where? From the ground, from its foundation. It grows up.
Yeah, from all the energy. Yeah, from all the minerals and the sun energy and all that. Yeah.
It's as simple as that. It's very, very simple. Energy is always transferred. It has to go somewhere. It can just not stay anywhere. It has to move to something.
But once again, man, something makes up from down. They're definitely different. And me, that's always going to be nagging at me, no matter what I say, or no matter what I hear. It is all, for me personally, it's always going to be in the back of my mind that, dude, it's something fucking different. I'm way to the ground, and to me, it's always going to be nagging at me if I can't figure out a cause for my own self. But as far as proving it, I don't know, man.
Yeah. Yeah, but I mean, how boring would life be if
you got to admit, dude, I know it ain't just me. Like, you've thought about this a lot. Whatever conclusion you came to, you got to be honest and tell me you've thought about, damn, up is maybe the different from down. I mean, the explanation you have is a good one. It's backed,
Yeah.
And all that. But have you thought about this a lot, man? Or is it just me, or
really.
what?
You see, I think the mindset that people have is, especially from the globe, when you come from the globe side, you have the foundation of, I need something to hold me down. Otherwise, I'm going to fly away. You understand? That's what they need gravity for. But if you change your mindset to, I don't need anything to pull me down. I'm simply down where I am because I'm denser than the air around it. It can't support me. So I'm at my foundation. Then you realize there isn't a bias down. It's simply the natural order of me being denser than the medium. So I am at my foundation. That's why I say, where was I born? I was born on the ground. I wasn't born in the sky or whatever. But if something's denser in the sky, it's obviously going to come down because it had to first create energy to get there. Nothing starts in the sky, it starts at ground.
No, there's a big magnet underneath this, man. No doubt about it. No, I'm just kidding. Hey, but I can say this though. Here's another interesting direction to go with this. So, like, I can prove. I mean, this kind of might lead to density though, kind of. But I asked the ballers, like I ask them, because they say that it takes a force to move something. There's got to be a force to move something. And then I ask them if heat's a force, and they say no. I'll ask them if heat. Can you move things with heat? They say yes. And so 2 questions in a row, they contradict themselves. They say, yes, a force is necessary to move something, and yes, you can move things with heat, but no, heat's not a force.
Yeah.
And to me, that's a direct contradiction. So I could probably take the water that Anthony Riley took for his egg experiment and cooled it down to just above freezing, and we might have got the same effect, or heated it up and sink. Just from heat. But then you could say, that's changing the density of the medium, which it is, but it's probably changing other things too, like the pressure, there's just a lot in this that people don't really think about, to me. I think there's a lot of different ways to look at this whole thing.
Yeah.
But it all boils down to mainly the medium.
Yeah, I know Witzer talks a lot about this, so he might be the man to try and get on here to talk about it. Because I know Witzer does talk a lot about I think he's also talked about the spider ballooning and the bumblebee and stuff, so I think it'll be interesting. We can get everybody in. We can talk together about it. I think it'll be quite cool. Just to get everybody's take.
Yeah, man. You know what? I'll do that, man. I'll message him. You message him, and I'll message him.
Yeah.
He's pretty busy, you know, but he gets my messages. You know, not always right away, but you know, he gets through to him, and he's got some interesting fucking ideas, man. That kid is doing a lot, man. I wish the hate would stop, man, because that kid's done a whole lot, man. He's went around, and you know, he's just shit, dude. He's all in, man. He's all in. I don't know what else a motherfucker could do. Coming up with some interesting ideas that people don't agree with, but let's cut him some fucking slack. He's got some hellacious good ideas, man. Maybe they all ain't right. Maybe they are. Let's talk about them without freaking out, you know?
Yeah, he is trying. But yeah, like I said, if we can get everybody together and talk about it, it'll be really interesting to have the conversation.
Okay, man. Well, I'm gonna let it ride, man. I wanted to bring that up. I wish I could have not butchered it so bad. You know, it would have probably been a little more interesting to talk about. But like I said, I'll go back and listen to it. It wasn't the spider balloon, and I think it was the pollen thing, and I think they had the footage of it. But either way, whatever it turns out to be, it's a fun conversation, and I'll reach out to Austin and a couple of the other guys, maybe Jeremy, and I'll come back to you and let you know. And maybe you can give us a time, and we'll see if I can get him to join. But I appreciate you having me, Flatsoy.
Thank you for coming. Like I said, I'm very, very happy if someone comes and gives their opinions and stuff. I do really appreciate it, and it's you guys that make the channel. So I do not disrespect anybody with their different views. So yes, please, really don't. I don't want anybody to feel they cannot come here and give their views on something. That's not my aim of the channel. I want to accommodate everybody.
Roger that. Peace out, brother.
You too, man. Thanks for coming. Cheers. So Michael is still there.
Yeah, I'm still here.
I see that Sean Hawkins is keeping you busy in chat.
I was keeping me busy on Discord as well.
Oh, man.
The sad bastard.
Yeah, I think because PJ also told me he enjoyed the members only thing last night. So I was thinking I was thinking maybe at least once a week for you guys, just to say thank you for all you guys, your members and everything. I'm gonna do a members chat every Sunday night. I think that
I noticed that all mods got in as well, didn't they?
Yeah, all the mods. Look, all the mods and members are free to talk with the mods only. The members only chat, and it was nice and chilled in the chat. Everybody could just relax, and we could all, you know, just relax, because at the moment these trolls are keeping you guys so busy. It's a work.
I think with me, I'd just ban them all, like.
But yeah, it's good to.
I mean, they're just coming in and just slagging people off and just, you know, just spreading Discord throughout chat. So I don't see why they have to be here.
Yeah, they don't even concentrate on what a person is saying. They just literally come here and say, "No, you're wrong. No, you're wrong," and that's about it. They don't think further. They don't actually listen to the argument. They literally just come to try and vote on a poll to make it seem that they're winning somewhere, but usually they misunderstand the poll. And yeah, that's about it. I mean, look at last night's poll, where it was a catch-22 poll, where you ask, is McToon honest with perspective? So if you said yes, you're saying he's honest, but then you're showing he's ignorant to what perspective is. He doesn't actually know what it is. But when you say no, he's been...
In his entire presentation on perspective, he just proved himself to be a liar within regards to
perspective,
celestial navigation.
Yeah, exactly. He debunked himself.
Denied triangles and trigonometry. Denied it all, hasn't he, for celestial navigation?
Yeah, he actually debunked every argument he's ever had about celestial navigation and triangles and trigonometry by bringing that up. But like I say, the guys don't get that. So the poll tonight, out of 83 votes, do you understand relative density disequilibrium? Yes, 47%, no, 43%, and almost there, 10%. Guys, I did show a demonstration myself twice on here, so it's in the beginning and a little bit further. So if you haven't watched it, maybe after the stream, go and watch it. It will be well worth it so you can understand it better. PJ Crunchak, Fletcher's perspective and Michael Kahn, it was brilliant. Yesterday, loved it. Can't wait to get on Discord, broadband, or other. Yeah, it sucks that PJ can't really chat because at the moment he's on his normal data, so he can't really chat. That sucks. Mahang, Sean's usually right. That's probably Sean's one sock because Sean is never right, guys. I'm sorry. Sean Hawkins is never right. There's no from usually right. So that must be.
If you let him get to more than 2-3 comments, and he usually just debunks his Sam.
That's actually a good thing, Rachie. Maybe the question to ask is, what don't you understand about RDD? Yeah, that'd be great. Anybody that here has any questions about RDD in the chat, yeah, let me know. Tag me in or super chat me or whatever, and I will try and answer it to the best of my ability. Or you can come in Discord and chat about it as well. That'd also be great. Oh, sorry. There's just something in my child's arm. I'm gonna be back now. Is it okay? Okay, yeah. The children aren't sleeping yet. Can you believe it? And it's already 10 o'clock. What a mission to get the children to sleep. Yeah, so if you have any questions about RDD, this is your chance. Just tag me, super chat, or come into Discord. I'm more than happy to try and answer it to the best of my abilities. Wow, it's hot here tonight. Let's see. I see, Michael, you got a video that you sent me in Discord. Do you want me to show it?
It was Brian's video.
Yeah, from Brian, yeah, flat earth test. You want me to show it?
Yeah.
Because I can.
Yeah, it's up to you. Your stream.
Okay, let's go to it because I mean it has got to do with refraction and density and stuff, right?
But refraction just makes it.
But there's a camera ones it well.
Okay. Ruby, I don't need 80. Okay. Let's see if it's showing. So yeah, Brian Leak, he was on earlier. Guys, if you haven't already, do subscribe to him. Flat Earth Tests. Really great channel. Let's see what he has to say.
But refraction just makes it worse. Refraction in the air makes distant things appear slightly higher. Oh, you mean like the ground?
So when we show globers horizons that are way further than they're supposed to be according to the math, they claim refraction. And they demonstrate this by putting a bunch of sugar and letting it dissolve at the bottom of the tank full of water.
Yeah, very interesting that day. And it's weird how when you shine a laser light through water like that, it goes down, not up.
Making a denser medium down low, simulating the Earth's atmosphere with denser air closer to the ground.
Yeah.
So they'll shine a laser through this setup and show it bending downward and say, since the light's bending downward, that objects appear higher in the distance. And this is how they explain all the thousands of videos we've shown of objects that should be hidden by Earth curve. So let's take a close look at it and see if that's what happens.
Yeah, so even relative density plays a role with refraction, guys. Hence why we have density. Weird.
Very cold in my garage.
Got about 6 gallons of water in here,
yeah.
And I'm going to add around about 5 pounds, I think.
Okay, I'm obviously not gonna watch the whole video. If you guys want to watch the video, then do go on Brian's channel, Flat Earth Tests, and watch it and subscribe to him. Definitely well worth it.
So what I ended up doing was removing some of the water and just lowering this curve a little bit.
So that ramp at the bottom is supposed to simulate Earth curve. You say you lowered it. But look at the rim around the entire bottom of the fish tank. It's higher than the ramp. And this
yeah, why is he showing a ramp anyway?
It's going to be important later, so remember that.
Okay.
It's a little bit too much for my knees. But what next direction, if you get a camera here, which I'll put there in a second, well, the line of sight from the camera.
Interesting, the line of sight, yeah?
Will go up, over, and down, which means it will go over this obstruction here.
It's going to go over the obstruction, guys. So in other words, he's trying to say the refraction goes up around the curve. But remember, refraction has got to do with angle of incidence. So if you change your angle of incidence with the laser, it's going to change what you actually see.
If you see, I send this light beam out,
look how he's pointing it upwards in a denser medium, so it's going to have that arc because it's pointing it upwards and going down. So if he really wanted it to give it like they claim it, he should be having it at a flat horizontal showing it going up. But remember, the density is at the bottom, thanks RDD, so it's going down, not up.
And it actually bends down.
Bends down. What did McToon say? It bends up.
Right over the other side. It actually goes over this little lump of metal I have here.
You see the lasers off to the side?
Yeah, he puts it on the side of the hump. But yeah, we already saw this, so yeah, guys, just go and watch Brian Leak's flat earth tests. See what he says?
Gradient's doing. It's not making things look higher, is it?
Refraction in the air makes distant things appear slightly higher.
Yeah, that's a cool story, McToon. But like most of your stories, they don't line up with reality. You need to stop lying to people.
100% agree, Brian. He has to stop lying to people because that's what he does. Hence why he thinks orthographic view is perspective, because he doesn't actually know what he's talking about, but he's still pushing it as knowing. So guys, yeah, flat earth test, do go and subscribe to. So yeah, very, very simple. Kan jy op hom praat asseblief, ek is besig, gaan kamer toe. Ek's besig. Sorry, my child is just very, very loud. Jolly man, atomic hydrogen, clean free energy, elemental transition, natural collisions, plasma and clean process are energy creation, invention, right? Secrecy Act 1958. Is there? That's quite interesting. Invention Secrecy Act of 1958. I still do think there is a lot of technology out there that they do keep from us. So, yeah, very interesting. I think Flatzoid removed them all a lot at some point, then gave them out again. Yes, I did. Raichi, I banned quite a few of them because after they get warned, by the way, and then they keep creating sock accounts. So then I decided they're crying, let me unban them again. I gave them a choice and they come and do the same rubbish again. So I warned them and banned them again. And they're still here with more sock accounts. So what does it help to ban? I think I'm sitting with over 200 banned accounts on my channel and it's still the same people's sock accounts trolling. Very sad. Light doesn't bend, it propagates in parallel lines. It does refract and appear to bend, but it's simple, reaching our eyes slower, creating the effect. That's quite an interesting take on it. I would still say light does bend because you can actually literally see the bending of the light. Or is it just an apparent bend? I don't know. Hey, can you stop with it? But then again, what is light, Jolly Man? If you guys haven't already watched it, I do have a video series on what is light. It's a 2-part series. You might want to watch that because it's got to do with interferometry. It's got to do with the double slit and the single slit, and showing that light doesn't interfere with itself. I did bring this up to Globusters as well and asked them if they would actually look at it and give me a response to their claims on the ring laser gyro picking up the ether drift, because light cannot interfere with itself, therefore it cannot pick up the drift of the ether and it cannot pick up the drift of the earth. So the globe has a problem there and the guy's claiming it to pick up ether. Just saying. So yeah, I think that's about it for tonight. I'm going to try and get my children to bed because they are not listening to me while I'm talking to you guys. Children just don't want to listen. And they should have been in bed an hour, almost 2.5 hours ago. So I think it's time I get them to bed. So again, the last time on the poll, 87 votes. Do you understand relative density disequilibrium? Yes, 49%, no 41%, almost there, 9%. So yeah, again, thank you all for coming. Do really appreciate you all being here. Thank you all the people that have become members and all the mods. Thank you for keeping the chat in bay. Please just hit that like button and the share to get the 2 more people. You guys are really, really awesome. I do appreciate you guys. And for those that want to support me financially, I do have a PayPal link in the description box below with even a Bitcoin link or whatever, and merchandise. So again, you guys all rock. Thank you once again for everything. 100% Rachie, you deserve the wrench. So awesome, guys. Till tomorrow night, same time, same place. God bless.